Students, in the last lecture we have done about order of the reaction. Now what are elementary reactions? The reaction which takes place in one step, means single step reaction, is known as elementary reaction. Next, complex reaction. A sequence of elementary reaction means the reaction which occur in number of steps. For example, consecutive reaction like oxidation of ethane to CO2, and H2O passes through a series of intermediate steps in which alcohol, aldehyde and acid are formed. Complex reaction means which occur in number of steps. Now the important topic is units of rate constant. Rate constant is denoted by K. Let us consider a general reaction AA plus BB gives CC plus DD. So rate law will be rate is equal to K, A to the power X, B to the power Y. X and Y are determined experimentally. So order of the reaction will be X plus Y. X plus Y means the coefficient present in the rate law. So by this reaction, K is equal to rate upon A to the power X, B to the power Y. We know units of rate is equal to concentration upon time, and A and B are concentration. So I have taken concentration to the power N. So by this reaction, K will become concentration to the power 1 minus N divided by time, means concentration 1 minus N time inverse. This is the unit of rate constant, general units. Rate constant unit depends always on the order of the reaction. For zero order, N is equal to 0. So by putting the value of N equal to 0, we get K is equal to concentration to the power 1 time inverse. Concentration units are mole per liter and time is in second inverse. So the unit of zero order reaction rate constant is mole per liter per second. For first order reaction, N will be 1 minus 1 equal to 0. So concentration raised to the power 0 time inverse, the unit will be second inverse or R inverse. In the question, if K is equal to 2.3 into 10 to the power minus 5 liter mole per second, find order of the reaction. Here this value is given only for the confusion. These units can explain about the order of the reaction. Only see the units for the value of order. So reaction will be second order. Next topic is molecularity of a reaction. Molecularity is the actual number of elements or atoms or ions participating in a reaction. The number of reacting species taking part in an elementary reaction which must collide simultaneously to bring about a chemical reaction is molecularity. What is the difference between order and molecularity? Order is calculated experimentally and molecularity can be find out theoretically by only see the reaction. For example, the reaction is in unimolecular when one reacting species involved. For example, this is ammonium nitrate, only one reacting species involved, so reaction is unimolecular. Here two molecules of HI are involved, so reaction is bimolecular. Probability of more than 3 molecules colliding and reacting simultaneously is very small. Complex reaction which occur in number of steps. Here the order can be find out. This is very important. For complex reaction, order can be find out only by the slowest step. Let us consider the example 2H2O2 gives I negative. In the presence of I negative gives 2H2O plus O2. This reaction occurs in 2 steps. These are the 2 steps. First step is slowest step. So this slowest steps is the rate determining step. So order will be K H2O2 plus I negative. So order can be calculated by slowest step. Molecularity have no significance for complex reaction. Next we come to characteristics of rate constant, that is K. Greater the value of K, faster is the reaction. Each reaction means different reaction has a different value of rate constant at a particular temperature. I told you earlier, units of K depends on order of reaction, and value of rate constant does not depend on the concentration of reactant. Now the important differences. First difference is difference between rate of reaction and rate constant, and second difference we will do between order and molecularity. So first is rate of reaction and rate constant or specific reaction rate, that is K. Rate of reaction depends on concentration, and rate constant is independent of the concentration. By the definition, it is equal to decrease or increase in concentration of reactant or product per unit time. It is proportionality constant in the rate law. It decreases with progress of reaction. As I told you earlier, does not depend on the progress of reaction. Rate of reaction units are always mole per liter per second because it is change in concentration upon time, and concentration units are mole per liter and time is in second. And rate constant units depends only on the order of the reaction. Next difference is between order and molecularity. First the definition comes. Order is in the rate sum of concentration in rate law. Molecularity is actual number of ions, molecules or atoms participating in the reaction. Order can be fractional as well as zero. It cannot be zero. Zero means no reaction takes place. It is always determined experimentally, it is determined theoretically. It is applicable to both elementary as well as complex reaction. It is applicable only to elementary reaction. Example of the type of reaction depending upon order: zero order reaction means rate law depends not on the concentration of H2 and Cl2. First order reaction, second order reaction. Unimolecular, bimolecular and termolecular. Next, some problems related to order of reaction. Calculate the overall order of a reaction which has rate expression this and this. Order of the reaction can be calculated only by adding the concentration term which are present in the rate law. So from first equation, 1/2 plus 3/2 will be 2, that is second order. And from second one, 3/2 minus 1, it will be 1/2, it will be half order. The next question is the conversion of molecules X to Y follows second order kinetics, means the reaction is of second order, so rate depends on X to the power 2. If concentration of X is increased to 3 times, how will the rate affect the formation of Y? So rate is, let us consider the concentration of X is A, so rate will be K A to the power 2. If according to the question, if X is increased to 3 times, means earlier the concentration was A, now it will be 3A, so rate will be K 3A to the power 2. 3 to the power 2 means 9 Ka square. Earlier the rate was Ka square, now the new rate will be 9 Ka square. So rate of formation will be increased by 9 times. Thank you.